So also in this section, we're going to look at compound interest. The compound interest formula is the formula A equals P times the quantity 1 plus R over N, all raised to the N times T power, where A is the amount obtained after T years from some investment at an annual interest rate R compounded N times per year. And we're going to use this thing here in a minute. But I want you to notice the second formula here, continuously compounded interest formula, really looks just like our exponential growth formula. The only difference is that we don't have a Q and we don't have a Q sub 0 here, and we don't have a K, we have an R instead. But otherwise, it is actually the same thing as exponential growth. So continuously compounded interest formula is A equals P times E raised to the RT power, where A is the amount obtained after T years from a principal or an investment at annual interest rate R compounded continuously. So let's actually look at using these two formulas. Now, when we see just regular compounding semi-annually, annually, quarterly, monthly, daily, those are all the compound interest formula, and we will plug into that formula. But when we see the word continuously used, we will plug into the second formula. So let's take a look here. You put $10,000 into a CD at interest rate 4% and are going to leave the investment in for 10 years. How much will be in the account after 10 years if interest is compounded? First quarterly, monthly, and then daily. Oh, and I left one out. I want D to actually be continuously. And then finally, we're going to answer the question, how long will it take for our investment to double if we are compounding continuously? Okay, so let's start with quarterly. Quarterly is not continuously, so we will use the compound interest formula. Now let's identify. The $10,000 is our P. It is our original principal or investment. 4% interest rate is our R, but we always want to put R in as a decimal, so as 0.04. And we're going to leave it in for 10 years. T is 10. So first, we want to know how much will we have at the end of 10 years if we compound it quarterly. Now let's realize that quarterly is 4 times per year. So N is 4. So let's fill into this compound interest formula. A is equal to our principal, $10,000, 1 plus our interest rate as a decimal is 0.04 divided by 4, raised to the N times T power. So N is 4, T is 10. All right, now, very important how you stick this thing into the calculator. And I suggest you do it in steps so you don't make mistakes. So what I'm going to do first is I'm going to put the 1 plus 0.04 divided by 4 into my calculator. That way you can kind of check yourself at every point. That is 1.01. And then I'm going to go ahead and multiply the 4 times 10. And it's very important that in our exponent, we multiply that before we actually raise our 1.04 to the 40th power. Now you have to do the order of operations here. You do not want to multiply that 10,000 times that 1.01. Order of operations is to do the exponent first. So let's take 1.01, raise it to the 40th power, and I will get 10,000 times 1.488863,734. Now I'll round this off in a minute. After my final multiplication, let's multiply that by the 10,000 now. And we get that I have $14,888.64 at the end of 10 years. And now, of course, I'll round off 2 cents, since that's a reasonable thing to round off to. All right, now, let's do the same thing, but let's do it for monthly. Monthly would be 12 times per year, so N is 12. And the only thing that will change here is our N. So this will be a 12, but it also will be a 12 right here. All right, so I'll have A equals 10,000, 1 plus 0.04 divided by 12, raised to the 12 times 10. Now let's do the same thing again. I will do the 1 plus 0.04 divided by 12 in the calculator. And that doesn't round off as nicely, unfortunately. So I'm going to have 1.00 and then just a bunch of repeating threes. All right. And then, oops, my parenthesis accidentally was a 9 there. All right, there we go. And then I'm going to multiply 12 times 10 first before I actually work this out. So that's 120. And now I'll take that repeating decimal to the 120th power. I get 1.490832682. And now I will multiply that by 10,000 and I'll get 14,908.33 cents. All right, so let's now go to daily. This time, the only thing that's going to be changed is our in again. Daily means 365 times a year. All right, so let's change this 12 to 365, and also we'll change it to 365 right there. So we'll have A equals 10,000, 1 plus 0.04 divided by 365, raised to the 365 times 10. And then let's work this out. So again, I'll do the 1 plus 0.04 over 365 first. That'll give me 1.000109589. And then let's go ahead and multiply our 365 by our 10. So we're going to raise this to the 3,650. I will do my exponent first. So this number to the 3,650th power. And I end up getting 10,000 times 1.49179203. And then when I multiply that out and round, I'm going to get $14,917.92. Now, I'd like you to notice that the more often we compound, the greater the balance is. So when we compounded 4 times, we had $14,888. When we compounded 12 times per year, we had 14,908. And when we compounded every day, we had 14,917. So if we compound continuously, we can expect our balance to be still probably in the 14,900 range, but a little bit more than this one right here. So let's look at continuously. The word continuously is there though, so we're going to use the second formula. We're going to use this formula right here. So let's plug in. We still have 10,000, but now we're going to have E, and we're going to raise E to the 0.04 times 10. All right, now before we put this thing into our calculator, I'm going to go ahead and multiply that 0.04 times 10. That's where people make the biggest mistake when putting things into their calculator. So this is 10,000 e to the 0.4. And now I'm going to put e to the 0.4 into my calculator first. Now those of you with graphing calculators, you can do this immediately. It's not going to hurt to do that. But for those who are just using simple calculators, it's better to do it a step at a time. So let's see, I get 1.49182469.8. And when I multiply the 10,000 times that number, we get $14,918.25. Now notice that it's not much more than daily. It looks like maybe 30-some cents there. All right, but it's still more money. And if you start thinking about this a little bit, banks tend to, for savings accounts, they compound quarterly or monthly, giving you less of a balance. However, for credit cards, they compound daily or continuously in order to give them more money. So you're paying them a lot more interest. So there really is something to how often something is being compounded. All right, now let's answer our last question. How long will it take for your investment to double if we are compounding continuously? Okay, so we're going to use our compounding continuously formula. Our investment is $10,000. So when it doubles, it'll be $20,000. So what we're going to do is put $20,000 on the left side of the equation. Still have our $10,000. We still have our E. We have it raised to the 0.04, but we don't know how long, so T is our unknown. And we're going to solve this equation. Now let's notice this is an exponential equation. Let's identify that here's our exponent and E is its base. So we need to get E to the 0.04t by itself on one side first. So let's divide out the 10,000 that's with it. So I'll divide on both sides by 10,000. Over here I get 2. And then recall our next step in solving an exponential equation is to apply the natural log on both sides. So we'll have the natural log of 2 and the natural log of E to the 0.04t. And normally our next step would be to move the exponent to the front, but remember the special case. Here the natural log and E always cancel each other out, so we're going to get 0.04t. And then let's finish solving for t. Let's divide out the 0.04 that's with it. And then we'll have our answer. Now what I've got written right there, let's go ahead and put it in the calculator, but be careful when your natural log opens that left parenthesis, be sure to close it right here or you will get the wrong answer here. So natural log of 2 and divided by 0.04, it is going to take 17, and I'll round it off to 1 decimal place, 17.3 years for this to double. And 4% is pretty low interest rate, so that's why it's taking so long for this to double to 20,000.